All right, guys, we're going to solve this common algebra problem here in a couple of steps and then talk about how to convert this over into what would be more of a algebraic proof format. So hopefully looking at this first move, you might see this 3 that is, there's no symbol in between the 3 and the parentheses, which is implying multiplication. We're trying to take 3 times everything inside these parentheses. So we need to actually, some of you might even remember we call that, we want to distribute the 3. We would do 3 times x, and we would get 3x. 3 times the negative 2, and we have a negative 6, and we haven't messed with the right side of the equation yet. So it's our first move. Generally a great idea is to try and get all of the variables on one side. I highly recommend looking, seeing, all right, which side has the most variables? Well, the right side has the most variables. You'll keep yourself out of a little bit of trouble if you move everything to that side. So if I don't want any of these x's on the left side, I want them all on the right side, that means I'm going to get rid of all those x's. And if I get rid of all of those x's on one side, I got to do the same thing on the other side. Let's see where we are. I had 3 x's. I got rid of all of them. I got no more x's on that side. The only thing I have remaining on the left side is a negative 6. 5x minus 3x. Now I'm down to 2 x's, and I still have a minus 15. So I just moved all of the x's to one side. Now I want to pull all of the numbers away from that variable x. I want to get down to x equals some number. So first, I'm going to move the number furthest from x. If I see subtraction, if I want to make this go away, I'm going to do what's called an opposite operation. The opposite of subtraction would be addition. If I add 15 on the right side, I'm going to need to add 15 on the left side. And let's see where we end up. So on this left side, now I've got negative 6 plus 15. It's a difference in signs. So we actually have 9 left. And then on the right side, I had the negative 15. I added 15. That makes 0, which in essence is gone. All I have left is the 2x. Now I'm really close to where I want to be. I just want to have x left. If I want to get rid of that 2, I have multiplication, again, going on in between there since I don't see a symbol. If I want to move a number to the opposite side of the equation, I'm going to do the opposite operation. Opposite multiplication, division. That'll 2 divided by 2 gets me down to just 1x. And 9 divided by 2 gets me down to either 9 over 2, or you could even just say 4.5, 4.5. That's a general algebra problem, all right? And it's really, we're not going to do it too much different if we want to convert it to a proof. But a proof just means we need to, for every statement that we have, we need to have a reason to make such a move. So on the left, we are going to have our statements. On the right, we're going to have our reasons. And I want you to understand, we really have done the entire proof, but we just need to have a reason for every move that we made. The first move, this equation, came from Crazy Coach Foss. That was provided to you. Usually the information that's provided to you, we're going to call that our given information. All right? Now, do you remember why we were able to make it step 2? We had this 3. We ended up distributing through there. That's actually referred to, just like we said, it's the distributive property. So for every distributive property, for every move that we make on this left side, we need to have a good reason on the right. Now, not in every proof will you see this, but we can actually show our work in a proof. All right, the way this will change, instead of showing subtraction on both sides, we're just going to make a crazy announcement that says, since 3x is the same thing as itself, then we can do something to both sides of the equation. Every time we say something is the same as itself, that is a simple reflexive move. It's one of the properties that is easier identified because we're just saying something is equal to itself. All right. And since 3x is the same thing on both sides, what did we do? We took 3x from both sides. So the way we ended up here was through the subtraction property. Again, we're showing our work here. Instead of showing the operation here, we're going to announce to everybody in step 5, since 15 does actually equal 15. And again, some proofs, you don't need this reflexive step, but I really recommend if you're just new to proofs, you make that reflexive move and it kind of shows everybody the direction you're going. So what did we do with 15 on both sides? We added it on both sides in order to get here. It's the addition property. Again, we're down to, we did something with 2 on both sides of the equation. This is our reflexive move. And the way we were able to get to our very end move was we divided 2 on both sides. So this would be, we're announcing that we made a division move, the division property. So that is a way to take a normal algebra problem that you already know how to solve and convert it into a very slow, methodical walk through, trying to show everybody a reason for every move that we made on the left. All right, that's all a proof is. It's ideas that you already know, but can you slow it down and go step by step so that somebody can really follow your way through the problem. Good luck.